Hello, my name is Maria and I'm going to present my final project for the Introduction to Python class. The goal of my program is to analyze the results of a Bradford assay, which is a relatively simple biochemical assay used for the quantification of total protein in experimental samples based on a standard curve. For the purpose of this presentation, I won't focus on how we get the data and what they mean, but rather I'll focus on the steps of the analysis. I'm using the following libraries: Pandas, NumPy, SciPy, and Matplotlib. In the presentation, I'll use a Jupyter notebook, although the final version of the project is a Python program which runs on the command line, which I'll show you at the end. The results of a Bradford assay are always a table of, or a list of numerical values. The machine that I use at work to generate these values gives me an Excel file which looks like this. It is an 8 by 13 matrix where the first 12 columns of each row represent data, and the last column is information about the assay that is not used in the analysis. The values from A1 to C3 are our standards measured in triplicate, where every 10th value is a replicate. For example, A1, A10, and B7 are replicate measurements of the same standard. The values from C4 to H12 are the experimental samples run again in triplicates. However, here C4, C5, and C6 are an example of replicate measurements. As you can see, there is some regularity of the placement of samples and standards, but it is much easier to utilize this if the data are presented in a one-dimensional vector. So the first things I do with my data are to remove the last column from the original file and rearrange the data frame into a series and then convert that to a list. I then calculate the average and standard deviation of each standard and then fit the standard curve data to a 4-parameter logistic curve. The final step of the standard curve is to plot the protein concentration of each sample versus its Bradford assay result together with the 4-parameter curve fit, resulting in this plot. Now it's time to average our triplicate measurements of the experimental samples and calculate the standard deviation. Based on the curve fit of the standard curve, I calculate the total protein concentration of the samples. And I also like to plot the experimental samples together with the curve fit just for visual inspection. So it's this plot here. The final step is to make a new data frame that contains the sample names and their calculated protein values, and to save it as a new Excel file. So here is a straightforward and fast way to analyze Bradford assay results. A potential extension of this program would be the ability to work with all possible file types such as CSV and text, and also different layouts to be more generalizable. And now I'm going to show you how it works on the command line. So here is our directory where I have my Python program and a Bradford.excel file. So we're going to call Python the program and the Excel file and run that. And if we look at the directory now, we have the standard curve figure saved. We also have our samples together with the standard curve fit figure. And we also have a new Excel file of the samples and their protein concentrations calculated.